Building Blocks, Section 3, Video 3. Algebraic proofs. Now, proofs don't just happen in geometry. We've been doing algebraic proofs for quite a long time, but the only problem is when we do algebra, we really never write down the reasons, and that's what a proof needs. So what reasons could we use when we do or solve an algebraic expression or equation? Well, here's what we have. And the four golden rules are the addition, subtraction, multiplication, and division property of equality. And what those mean is, for example, the addition property is that if I have a statement A equals B, if I add a constant to both sides of the equation, I will still have a true statement. So if I had 2 equals 2 and I added 3 to both sides, I would get 5 equals 5. It still equals. The subtraction property, essentially the same thing, but instead of addition, we are subtracting a constant from both sides. This should be then. Okay? So again, if you subtract or add the same amount to both sides of an equation, you have a continued true statement or equal statement. Multiplication works the same way. If A equals B, then if I multiply both sides by the same number, you will still get a true statement, meaning they will both still be equal. Division, if A equals B, and you divide both sides by the same amount, you get a true statement, equal statement. And we do those all the time. Solve by addition, solve by subtraction, solve by multiplication or division. We do that all the time, but never write down the reasons. And these are the reasons, and we'll use those in our proofs. A reflexive property seems kind of strange, but it basically makes the statement A equals A. And that sounds strange here, but eventually it'll be used quite often. Substitution property is very valuable. The substitution property says that if A equals B and A plus B equals C, then A plus A equals C. Now, that might not seem like it makes any sense whatsoever, but what happened? Well, since we said A is equal to B, this B can be rewritten as an A because they are equal in with respect to each other. So I basically put these two things together and I replace that second B with an A instead. That's substitution. Distributive property we're more familiar with and have used quite a bit, and that is that if A parentheses B plus C, then if you distribute that, you get AB plus AC. And this is what happened. That's the distributive property. The transitive property is if A equals B and B equals C, then A equals C. How do we get that? Well, it's actually a little bit of substitution, but if A equals B and B equals C, then A must equal C. This again will make more sense as we apply it and put it into context. We are going to wait with definition of square roots. And this ends Building Blocks, Section 3, Video 3.